Welcome to the Introduction to Computer Science, Basic Computing Concepts Including History. This is Lecture D. The component Introduction to Computer Science provides a basic overview of computer architecture, data organization, representation and structure, structure of programming languages, networking, and data communication. It also includes the basic terminology of computing. The learning objectives for this unit, Basic Computing Concepts, including history, are to define what a computer is, describe different types of computers, including PCs, mobile devices, and embedded computers, define the common elements of computer systems, describe typical hardware and software options for desktop, laptop, and server systems for home and business use, with an emphasis on healthcare systems, and explain the development of computers and the Internet, including healthcare systems, up to the present time. This lecture will conclude the discussion of the development of computers, the Internet, and healthcare systems. Up until the 1970s, computers were large, expensive, and were used by governments, large corporations, and universities. Over time, improved technology reduced the size and cost of microprocessors, which led to computers for personal use. The first available personal computer was the Altair 8800. It was available in 1975 as a kit or fully assembled. It was programmed with switches and output was given with flashing lights. Hobbyists, many of whom had worked with large computers at their jobs, flocked to these kits. Bill Gates and Paul Allen were some of these original hobbyists who developed a compiler for the Altair. They launched Microsoft to sell this compiler. At the same time, Steve Jobs and Steve Wozniak started Apple Computer Company in 1976. The Apple I was their first offering, and it was a kit. On this slide, there's a picture of the Apple I computer that shows how rudimentary it was. The Apple I sold for $666.66, which they thought was an interesting number. It included an etched printed circuit board, a bag of parts, and a 16-page assembly manual. The user had to provide his or her own keyboard, power supply, and monitor, which was usually a modified television set. When a Mountain View computer store called the Byte Shop ordered 50 units, Wozniak and Jobs attracted the funding to start Apple Computer. Apple I was not the first PC, but was certainly one of the most popular. It was followed by the Apple II in 1977, which came out with a keyboard, monitor, and floppy drive. The photo shows that it looks much more like the personal computers we know today. At the time that the Apple computers were becoming popular, IBM was watching very carefully and decided it wanted to get into this market as well. IBM knew that in order to be competitive, they had to be quick. They didn't have time to develop their own hardware and software, so instead, they used parts that were already available. The first IBM PC was based on the Intel 8088 chip. It used off-the-shelf parts and software, including compilers and operating systems from Microsoft. This, in turn, launched the success of Microsoft. Because its architecture wasn't proprietary, it led to the development of what were, at the time, called clones. Anyone could put together a PC using the same parts and design that IBM did. These were called clones. IBM PCs and clones were used for business and personal use and contributed to the personal computer becoming so popular. Another major change in computer technology over time is the amount of internal system memory. Early home systems might have had approximately 1 kilobyte of system memory. Today, 16 to 32 gigabytes is common. That is an increase of several million-fold from the systems of the 1970s. A commercial computer server can be easily purchased today with 96 gigabytes of internal memory. Increasing available memory is a demonstration of Moore's law, which is an observation that the number of components that can be placed on a circuit doubles every 2 years. This observation was made by Gordon Moore, the co-founder of Intel, in 1965. Significant changes in storage capacity have also occurred. While many forms have been developed over the years, this discussion will focus on the most common medium, the magnetic disk, in a hard drive. A 1956 article by Welsh and Porter describes a system that stores 250,000 12-digit words per drum, or a bit more than a quarter kilobyte. The chart above shows the growth to current capacities of disk drives in the terabyte range, or thousands of billions of bytes available today for home systems. Note that this chart is on a logarithmic scale versus linear. The capacity growth has been immense. The final trend is system connectivity. Early systems were standalone. They were not connected to one another or accessible from an off-site location. In the 1970s and 1980s, remote access and connectivity was beginning to be provided via dial-up connections. It became possible to connect a terminal at a remote location and display approximately 10 characters per second, and speeds began to increase. As with all other trends, the rate of growth was rapid, from 28 and 56 kilobits dial-up connections to the broadband speeds for home connections of hundreds of megabits per second today. Wireless connections are quite readily available. Wireless hotspots where computer users can access a public wireless connection are accessible, and worldwide interoperability for microwave access, or WiMAX, is one technology that can provide connectivity up to 54 megabits per second in some areas. Note that dial-up connections are still in use where broadband or wireless connections are not always available. However, with the rapidly increasing number of mobile devices that use cell phone connections, as well as the growing expectation of being able to access systems and services from anywhere, not from just a wired connection, this is likely to change. To summarize, significant growth has occurred in the availability and capabilities of computer systems since their inception in the 1940s. Expectations are that the trend will continue. Software was an integral part of the popularity of PCs. The most important piece of software on a computer is its operating system, or OS. The OS coordinates the hardware and all the other software on a system. The Disk Operating System, or DOS, was developed for Apple by Shepherdson Microsystems for coordinating the use of the Motorola chip in the Apple products. IBM needed an OS for their PC based on the Intel chip. It approached Microsoft, which didn't have an OS at the time. They did have compilers available for it, but not an OS. Bill Gates recommended talking with Digital Research, which did have one, but Digital Research didn't return IBM's call. In the meantime, Microsoft acquired QDOS from Seattle Computer Products, which Microsoft distributed to IBM along with their compilers and called MS-DOS. The rest, of course, is history. The smart, quick maneuvering by Bill Gates and Paul Allen helped launch the success of Microsoft with the initial IBM PC. The first popular software program was VisiCalc. It was developed by Harvard Business School students Dan Bricklin and Bob Frankston in 1978, and it was a spreadsheet program for the PC. Many businesses were very interested in spreadsheets for their many calculations. Over 100,000 copies of it were sold the first year. Other spreadsheet programs soon followed: Lotus 1-2-3 in 1982 and Excel in 1985. Word processing, which had been done on separate, dedicated machines, made a huge impact on the PC world. WordStar was first in 1979, followed by Word for MS-DOS and WordPerfect. Word processing is now one of the biggest applications for PCs. In the meantime, the first steps in developing the Internet were happening. In 1969, the Advanced Research Projects Agency Network, or ARPANET, connected 4 universities. It was a project sponsored by the U.S. government for connecting researchers. By 1971, there were 15 sites on the network, and by the 1980s, there were over 1,000 sites on the network. That's when the term Internet actually started being used instead of ARPANET to refer to the network. Other networks were formed at the same time and eventually all merged together to become what we know today as the Internet. In 1989, Tim Berners-Lee developed the World Wide Web software that is an interface to the Internet. In 1992, Congress voted to allow commercial activity on the Internet. Up until this point, only government-sponsored institutions and universities could use the Internet. In 1993, the first web browsers were released, and in 1997, PubMed, which offered free online access to Medline, was launched. The combination of several different factors led to the Internet boom of the late 90s. Personal computers became faster, cheaper, and smaller as technology advanced. This meant that more households and more people could afford to purchase them. Microsoft advanced their operating system and introduced Windows, which had a graphical interface. Now, users could interact with a computer using a mouse, which made navigating a PC much easier for most users. The Internet was open to commercial use, and web browsers made exploring websites easy. And this all led to the huge Internet boom, but it also led to the ubiquitousness of computers in our society today. This slide presents a brief history of early electronic medical records. Dr. Morris Collin began storing patient data at Kaiser Permanente in the late 1960s. Computer-stored ambulatory records, or CoStar, was developed at Massachusetts General in 1968. It is still in use today, and one of its defining features is its clinical guidelines reminders. Health evaluation through logical processing, or HELP, started at LDS Hospital in 1967. HELP also provided decision support, such as an automated antibiotic consultant. This tool helped physicians prescribe antibiotics more effectively and appropriately, which resulted in reduced dose costs and adverse events over time. The concepts and plans that eventually became the Veterans Administration VISTA were also developed in the 1970s. VISTA is a public domain software and was the first that used a graphical user interface for electronic medical record software. It is still in use today. As all these advances in computing and the Internet were happening, electronic medical records, or EMRs, got their foothold. More versions of them were being developed in the 1990s, and they became more user-friendly with the addition of graphical user interfaces. HIPAA, which is the Health Insurance Portability and Accountability Act, enacted in 1996, included provisions for establishing standards for electronic medical records. In 2000, only 16% of private physicians and less than 10% of hospitals used EMRs. By 2005, 25% of private physicians used EMRs, and the number has since been increasing. Computing has continued to advance since then. Some of the highlights are listed here. Personal data assistants introduced handheld computing, and cell phones have replaced PDAs. All of us now are very familiar with iPhones and Blackberries, which are small computers that we carry around with us every day and do most things that we can do on a laptop or desktop, but with limited screen size and limited memory. Wireless networks are now widely available, so mobile computing is pervasive. We now expect to be able to connect to the Internet everywhere and all the time. Social networking is another phenomenon that is developed through the use of the Internet and computers, which now connect people all over the globe. Computers and the Internet are ubiquitous. In 2009, the HITECH Act was passed as part of the Economic Stimulus Recovery Plan. It provides incentives for EMR use starting in 2011. This act led to massive increases in adoption of electronic medical records and electronic health records in clinical settings in our society. Tablets are a relatively new size and shape or form for computing, at least for common use, although they have been available since the late 1980s. They are designed for portability, tend to be small and thin, and do not necessarily require a keyboard to use. Adoption of tablets had been rather limited until the Apple iPad was released in 2010. It sold over 3 million units in the first 3 months it was available, and the iPad 2 sold over 1 million units in the first weekend it was available. This raises the question, are tablets a fad or a real trend in technology adoption? Many mobile devices use touchscreen technology. Some devices also have integrated keyboards as well as an alternative input device. These devices can be portable data assistants or telephone systems such as the iPhone, which integrate telephone capabilities with internet access, such as web browsers and email clients, not to mention millions of applications available for personal use. Some of these applications can be used for medical purposes, such as drug references. The question that arises is whether tablets and mobile devices will eventually merge. As the capabilities of mobile devices increase, is a tablet and a mobile device redundant? Think of a typical user. Would they want to carry multiple devices for access to similar applications? Is it really necessary to carry a mobile device for its telephone capabilities as well as a tablet for other tasks? It is likely that the two will merge into a device that has the capabilities of both in the near future. It may be larger than a current mobile device, but smaller than a tablet. Perhaps new technologies will allow size expansion as needed. Voice recognition technology has been used, at least in fiction, since the 1960s. Commercial applications currently exist, and voice recognition is built into some operating systems. Note that the quality of voice recognition is still not at a level to replace, for example, a medical transcriptionist. However, limited success has been achieved in specialized applications. Some current mobile devices can support voice recognition. The most well-known example is Siri, which first became available on the iPhone 4S. It is capable of responding to voice commands related to messaging, making phone calls, searching the web, checking the weather, and more. Both Macintosh and Windows operating systems have dictation and text-to-speech applications available. One device, called Vocera, is used in hundreds of hospitals. It provides clinical staff with intelligent mobile communication with wearable hands-free Vocera badge. The Vocera badge is worn by users, and simple voice commands are recognized for communication between the users. Some of the more recent changes in human interaction with technology have been enabled through newer technology. Most current mobile phones contain orientation software and accelerometers, enabling the system to know how it is being held and how quickly it is moving. This allows users to interact with applications without touching a keyboard, virtual or physical, or the device screen. One step beyond this is a remote device which sends this information to the system wirelessly, as in the Nintendo Wii. This permits interactive games that do not require users to be directly connected to the computing system. In addition to providing entertainment, interactive games are available, which encourage and direct personal fitness, a direct benefit to health. This concept is taken one step further in gaming technology. The Microsoft Xbox 360 Kinect allows users to interface with the system without a device through motion sensing. Microsoft's patent application refers to this as gesture keyboarding, allowing a user to make gestures that are recognized and acted on by the system. Since the capability for a user's gestures to be recognized is now available, what would it take for the user to be recognized? Imagine walking up to a medical record terminal, being recognized by the system, and starting a preferred application without needing to touch the system at all. There are advantages to thinking large rather than small. For example, a larger interface can increase the ease of sharing information or clarity in display. Why be limited to a computer screen? This slide shows another option, a tabletop system at the Future Warfare Center's Simulation Center. Finally, another new trend is flexible hardware. Rather than the rigid devices in common use, new flexible devices may be available in the very near future. Roll-up keyboards are already available today, and there is current research into organic light-emitting diode OLED displays, which will allow for a flexible computer display. There is also research into smart textiles, fabric with sensors and pixel displays. With the reduction in component size and the addition of flexible technology, suddenly many more options can be considered. Will computers fold up in the future and be stuffed into pockets like a handkerchief? Will computers be part of our clothing one day? The image on the slide shows an experimental OLED. So, where is all this heading? What's the future of computing? If you knew that, you would become very wealthy. We don't know exactly where things are going, but we do know some things. We know that computer technology is going to continue to become faster, more powerful, smaller, and presumably cheaper. We know that mobile computing is here to stay. The concept of cloud computing, which is all the data on the internet, is going to be a hot topic for a while. Are computers going to become even more ubiquitous than they already are? How are they going to do that? Are there going to be more and better computers? What's in store for healthcare technology? It's difficult to say for sure, but we do know that it will be interesting. We'll all have to stay tuned. This concludes Lecture D of Basic Computing Concepts, including History. In summary, personal computers were first developed in the 1970s. The Altair 8800 was the first, then the Apple I, Apple II, and the IBM PC. About the same time, the Internet was growing. In the next 2 decades, computers became faster, cheaper, more usable, and more connected. This all culminated in the Internet boom of the 1990s. Technology is still developing. It is difficult to predict what future developments are in store. This also concludes the unit Basic Computing Concepts, including History. In summary, this unit defined computers as electronic devices that input, calculate, and output data. Computers include not only personal computers, but also smartphones and the computers that are embedded in most electronic devices today. Some examples are appliances, automobiles, DVD players, just to name a few. Purchasing a new personal computer today requires doing some research. First, the buyer needs to consider what applications will be running on the computer. This will help determine options like the video card, monitor, amount of memory, and hard disk. Then, the buyer needs to set a budget. Online sites provide reviews and buying guides to help determine the best system for the buyer's budget. Finally, the computers of today evolved over hundreds, even thousands of years, from the simplest tools for counting to the complex systems they are today.